So moving on from there, I wanted to spend a little while talking about experimental data science. Experimental data science projects are not the same as established data science projects. They're in fact very, very different, and treating them the same will often lead to problems. In fact, many of the issues data scientists, businesses, and agilists have stem from this one misunderstanding. And it's a critical understanding to have. And any time that I've worked with projects or worked with people or spoken to data scientists or agilists who are having challenges in the data science environment, it very much comes down to this statement. The two types of projects are actually different, and you cannot treat them as the same. So just to very, very briefly recap on what those differences were, we've just heard about the established data science, so let's talk about the experimental stuff. So I'm just going to repeat what I said more or less earlier. They use new or experimental and emergent models. They are often very research-based in nature, and as such, they tend to follow a scientific process. And that means there's a lot of research, development, production of hypotheses, experiments to prove or disprove those hypotheses, and then a high level of refactoring to be able to develop more knowledge to work on. Very often there are close connections with academia, and that means that we are working with or implementing recent white papers. In essence, we are going to be working with new, emergent, or very cutting-edge models, or indeed we might be working with totally unproven models. And because of this, and because of the experimental nature, it means that from an agile perspective, we're actually in an unpredictable situation. That being said, experimental data science is very good for complex data and very good for complex problems. As the name implies, data science begins with data, and actually so do our projects. Before we begin a project, especially the experimental ones, we need to ensure that our data is fully prepared and ready for use. There are far, far too many projects that I'm aware of that have begun by diving straight into development, but that can cause a number of issues. Preparing the data up front can save a lot of time and a lot of challenges. Now, the first step in ensuring this data is ready to go is to go through an early assessment. This assessment asks a series of questions like, do we have enough data? Is the data even accessible? Can we get our hands on it? Is the problem we've been asked to solve actually solvable with the data that is available to us? And do we need to do a prototype to validate that? One of the biggest problems that I see with data science projects, as I said, is actually getting your hands on that data. Can we get it in? Can we use it? Is the data, in fact, on a hard disk somewhere on a closed system that we can't get access to? Is the data in a format that we can't even interpret? Doing an early assessment of the data will help us overcome those problems, or indeed decide that the project can't go ahead because of those reasons. After that, we need to start looking at the quality of the data. Now, we need to ensure data is or is not appropriate to the question being asked. If the data isn't appropriate to the question being asked, we can't answer that question. So factors such as completeness of data, or the time period the data is for, or even the relevancy of the data have to be asked. And that's where this stage comes in. And I should add on here that this is the sort of work which your data scientists can do, and they need some time setting aside for them to go through the data and start asking these questions. Next, we look at data preparation. The data preparation is where we get our hands on the data, we store it, we organize it, we clean it up, and we tag it. And these are all key elements that data scientists and data science communities and teams do. Getting the data, putting it in a particular form or format, getting it into a data lakes, organizing it so that it makes sense and it is consumable and that it can be accessed quickly, cleaning it out of any data that isn't relevant or erroneous data, and tagging it to make sure that to make sure the machine learning system actually can accurately recognize what that data is, more about that later, are all critical parts. And again, as I've said before, if you can't get hold of that data, it may be that your project needs to stop. But by making that assessment in the data phase at the beginning of the project, you can reach that conclusion without having spent too much money. Next, we need to assess the problem. Now, assessing the problem is where we start looking at what it's going to take to solve it. It's worth bearing in mind that experimental data science projects can take months or even years to complete. And I've certainly been on data science projects that have run for 18 months or more. So ensuring that we're asking the right question of the data and the right question for the business is pretty important. You don't want to get to the end of the project and find that you've built a model, but it doesn't actually answer the question we've been asked to solve. So this stage involves asking critical questions like, Is the problem clearly articulated? Is there actually value in solving this problem? Is this the right problem for the business to solve, or indeed is it the right problem for our customers to solve? And importantly, can the problem be solved relatively quickly? If it is going to take 18 months, let's be aware of it before we get into it so we can ensure that we have sufficient funding for it. If it's going to be solved really quickly, brilliant, no problems at all. But if it's a big problem, how do we slice it smaller so we can release value on a relatively regular basis so the business can see the direction we're going and we can actually release that value to the customer and actually make sure we're going in the right direction? And the last thing we need to do is define accuracy. And as I said, we'll talk about that a little bit later on. But again, just to recap on it, if we're building a system that recognizes faces, we need to ensure that it recognizes faces accurately enough, relatively often enough. So it might be that we set an accuracy level of 70% and consider that to be sufficient. If, however, we're talking about something like license plate recognition, then a 70% level accuracy probably isn't good enough. We need to be talking about 95 up to 100% accurate. So taking the time at the beginning of your project to actually define what that target accuracy is critically important, because it actually becomes your marker of done. If you don't know how accurate you want your system to be, how is it that we are able to say to the business, this thing is done, it actually does what it's supposed to? You could consider 70% to be accurate, but the business wants something much higher than that. So having those conversations right at the outset is critically important.